Hi, mathletes. This is a lesson about writing equations from context. That's like word problems. And at the end of this lesson, you will be able to write an equation of a function given information from various contexts. I included in this lesson a function summary of all the things that we've been talking about with our linear, quadratic, exponential, and absolute value functions. So I have all the different types of equations we've talked about for linear, and there's a lot of different ways that we can think about that. We have our vertex form for quadratic, our vertex form for absolute value, and then the standard equation for exponential. I'm not going to go through each of these things, but have a look through here, and if there's anything that's missing that you use or that you like to think about, annotate your page so that you have this. This is a nice one-page summary. I'm going to zoom in for question 1 to look at just the top half of the page here. So first we're going to read through the problem and maybe highlight or underline, circle some key information that we see here. Due to a drought, the canal from a reservoir is opened so that the reservoir is lowered to meet the irrigation needs for farmers. I hope this scenario sounds a little familiar to you because we talked about it at the beginning of the year, actually a couple times when we've done our card sorts and made posters of this. So this should seem a little familiar. The level of the water is being lowered from 160 feet by 15 feet per day until it hits its lowest point at 85 feet after 5 days. Then the water level begins to rise again. So that means we have a turning point. It hit a lowest point and it begins to rise at the same rate as it was being lowered. So this means that there's a turning point. Only two functions have a turning point, quadratic and absolute value. We have some key information here though. This 15 feet per day is our rate. And then it says we're using the same rate when it's going back up. So when we have two constant rates, hopefully that is bringing to mind a certain function. That function should be absolute value. And let's put some other key information here. We know that we start at 160 feet. It said it's being lowered from 160 feet. It hits its lowest point at 85 feet after 5 days. That is going to be our turning point when that is the lowest point before it goes back up again. So this situation we're going to be sketching here on the graph. Doesn't have to be super accurate, but we want to get the gist of the situation. And we want to fill in some information in our table here. So the first thing I'm going to do, I'm going to start with our table. We know that when no time has passed, the starting point is this 160 feet. So X is our number of days, Y is the water level. We start at 160 feet. Then it says we're losing water. The water is being lowered at 15 feet per day. That means on day 1, I'm 15 feet less. So, and I can denote that by a minus 15 for my change in Y. And 160 minus 15 is 145 feet. I'm not going to write feet because I have it labeled up here. After another day, again, it should be dropping 15 feet. That's going to give us 130, dropping another 15, and it's going to drop until it gets to 85 feet, which should happen after 5 days, and we'll check this out. So now we're at 115 feet. If we drop another 15 feet, that's going to give us 100 at day 4. Dropping another 15, that gives it at 85. So this right here is our vertex. And just to see, we have gone by ones. We were doing this day by day all the way down for the X's. This does not mean that our table is going to keep going. It tells us right up here that the water level begins to rise at the same rate. So this is our lowest point. So we are going to, I'm going to change colors here just so, like at 6, we are now going to be going up 15. So 85 plus 15 is going to go back up to 100. And if I do 7 feet, I'm going to add another 15. So that gives us 115. And you could keep going. I just wanted to make sure to add that to our table so that we can see that change. And now let's sketch a little bit of this on our graph. So our table is going to look on our graph, like we're going to take our X's along the X-axis. Those are the number of days. and the water level is going to be our y-axis in feet. And we need to get up to 160 because that's where we started, and we need to go down to 85. So we'll go down to 0 just to have our full scale, and our days start at 0. So with the days, I'm just going to go by ones here, and you can label this on your paper as well. But for the water, we're going to have to go by more than that. It looks like we have about 12. If I take 160 divided by 12 to kind of see how much do we need to have, probably a nice number because we don't want to have decimals, in there to have it be exactly 160. I think I'm going to go by 15 because if I go by tens, I'm only going to get to 120, and that's not going to work for us. So I'm going to add, I'm going to go by 15s. And you don't have to mark every one if you don't want to. If you want to just add 30 every 2, that is probably a fine idea for something like this. And so we know we'll be able to fit this. I am not going to plot every single point in my table. I'm going to pick kind of my key points. I'm going to take that starting value at 0 days, and 0 would be obviously on the y-axis. And we're going to go up to 160. So 150 plus 15 was 165. That would be right here. I'm going to go just below that, maybe a third of the way down from there, and put my dot right there for 165. And then I'm going to look at where my vertex is at 585. And so 585, here's 590. It's going to be just below that. And again, we're not looking for exact. It's about a third of the way down from there. And then we're going to go up from there. And maybe I'm going to graph 6 and 100 or 6 and 115 to kind of see, or 7 and 115, and plot that. So 7 and 115, we're going to go along 7. Here's 120. It's going to be just below that. And so that kind of gives us enough to be able to use a straight edge to sketch the shape of this. Let's use this information that we have visualized in our table and our equation to answer some questions. So we are going to, let me pan out just a little bit here so that we can see some of our questions with our table. And what type of function is this? This is an absolute value function. We've already talked about that. And we knew that it was an absolute value function because there was a turning point and opposite rate of change. So this one was a negative rate of change of negative 15 feet per day, and then it was positive 15 feet per day as the water was rising back up in the reservoir. The general equation for this is y equals a times the absolute value of x minus h and plus k. And so our turning point, our vertex, we marked in our table is 585, and our rate of change is plus or minus 15 feet over 1 day. And you can put just 15 over 1. I like to use my units to help me keep in mind what the situation is. And so to write the equation for this situation, y equals, now because I know that this opens up, I know that I want just positive 15 or 15 over 1 because it opens up. And then x minus 5 from our 5 days. And then it's plus 85 because we take the opposite sign. So this is a positive. I have a subtract in my equation. This is 85 as a positive. It stays 85 here based on this equation. Then we have some questions to answer down here. What will the water level be after 1 day, after 3 days, after 5 days, after 7 days, just to see. And we've already filled these actually in the table using the rate of change. We can do it algebraically by plugging these values in for x right here and solving for y. But we'll just use our table since we already have that. So on day 1, it's 145 feet. On day 3, and I'm just going to kind of write them underneath. On day 3, it was 115 feet. On day 5, 85 feet. And you can see that I'm getting this information from here. So 1 day is 145 feet. 3 days was 115 feet. 5 days is 85 feet. And then we figured out 7 days was back to 115 feet again. So you can just label those there. We use the table, using the table. Like I said, we can plug those in to the equation, the x values, and solve for y. We'll be doing that a bit more later in this lesson.